Hey guys, welcome back to learnix. In this video, we're going to be covering fractional indices. This is extended only, so course students skip to the next video. All right, so what are fractional indices, right? You already know what a whole number index is, right? So 2 to the power of 3 is basically equal to 2 times 2 times 2, right? Now, what happens if the index, which would be 3 in this case, is a fraction, right? So let's say we have 8 to the power of 1 over 3, or we have 25 to the power of 1 over 2, right? What does this mean? So the key to remember over here is that fractional indices are just another way of writing roots, right? They're just another way of writing roots. So let's say we have 1 over 3, right? This would equal to the cube root of 8, which we all know is 2. 1 over 2 indice would just translate to the square root, right? 2 here, 25, which will give us 5, right? Okay, so a rule to remember over here is, let me write it down for you, a n over m, right? So we have a fractional indice n over m, right? What this basically does is we write our base over here. N is the power, and m is what we are having like on the roots. Like let's say if m was 3, right, it would be a cube root. If m was 2, it would be a square root, right? If m was 14, it would be to the root of 14, right? And n, the numerator, would basically be our power, right? So if we have a 2 over 3, we would have a squared whole cube root, right? All right. So whenever you see fractional indices, think root. All right. So I have already explained you this rule. You have to remember this. Keep it in your mind so that whenever you have algebra, like x to the power of 2 over 3, you understand what that means, right? Keep this in your mind. A n over m equals to m root a to the power of n. All right. Okay, so now let's do some actual questions, right? Let's try to translate this into some real life examples. Okay, let me zoom in for you guys. So we have 8 to the power of 2 over 3, right? So what would this equal to? Remember, 3 is the denominator, 2 is the numerator. So we'll have 8 squared cube root, right? So what's 8 square? 8 square 16, right? So cube root, oh my god, what? The cube root. So what's 8 square? 8 square is 64, right? So what is the cube root of 64? 4, right? Now let's say we have 27 to the power of 2 over 3. Okay, let's just do that, right? This is going to be the same thing, 27 to the power of 2 cube root, right? And what this will give us basically is 3 squared, which will equal to, because 27 cube is equal to 3, so 3 squared equals to 9. Right now we have 16. You can do this in the calculator, by the way. It's not important that you know these by heart, right? 16 to the power of 3 over 4, basically same thing. Root of 4, 16 to the power of 3. It will give us 2 to the power of 3, which will equal to 8, right? Another simple way of doing this, you can also keep this power outside. So if you want, you can write this as the cube root of 8 whole squared, right? Maybe this will be easier for you because we know the cube root of 8 is 2, right? So it will be basically 2 squared, right? Which will give you 4, right? I think this method is a lot easier for people to understand, but sometimes they might mess it up and cancel it out. That really sucks. All right, let's try to do it with this one, right? So the cube root of 27 whole squared. We know the cube root of 27 is 3, right? If you don't, it's okay. You don't need to know that, but it will be helpful. And then just bring the square right over 3 squared, 3 times 3, that's 9, right? Super simple, super easy, all right? Okay, so Now let's say we have a negative fraction, right? Many people see negative fractions and they freak out and like, oh my god, I can't do this, and they just skip on to the next question. But it is super easy, right? So let's say you have 8 to the power of negative 2 over 3, right? Always remember, negative means flip it over, right? So we are going to have 1 over 8 to the power of 2 over 3, right? Uh, so basically, the power of 2 over 3 will apply to this and to this, all right? 1 to any power is just 1, so we'll have 1 over 8 to the power of 2 over 3, right? Remember what we did before? 2 is the numerator, 3 is the denominator, so 1 over the cube root of 8 squared. Cube root of 8 equals to 2, so it's 2 squared, right? And we all know that 2 squared is 4. So our final answer is 1 over 4, right? I am just writing all of these steps over here so that you can understand this easier, but you can skip a couple of steps. Like you don't have to do this step, right? No, you don't have to do this step. You can go straight to this, right? Or you can even, write this step, but then you don't need to go to this, and you can go straight to this step, right? Okay. I have some exam questions under here, but before that, let's try with some algebraic fractional indices, right? Let me move it over to this side. All right. So let's say we have x to the power of 1 over 2, right? That's going to be the square root of x. Let's say we have x to the power of 1 over 3, right? That's going to be the cube root of x. Let's say we have x to the power of 3 over 2, right? We are going to have, come on, square root of x to the power of 3. Very nice. And now let's say we have a slightly more complex example, 4x square to the power of 1 over 2, right? Now don't freak out looking at this. It's going to be the same thing. We're going to multiply this. We're going to take the indice of this and we are going to put it on that as well as that. So what is 4 to the power of 1 over 2? Basically, it's 4, the square root of 4, right? So we are going to write square root of 4, right? Now what about x square? We have a number which has a power and that has another power on top of that, right? We are going to multiply the power. So what's 2 multiplied by 1 over 2? That's x, right? Because 2 times 1 over 2, 2 is cancelled, we're left with 1, right? So we are going to be left with x, right? So what is square root of 4? 2. Answer is 2x, right? Don't worry if you don't understand that. I will be going into a better example over here, right? This is slightly more complicated. Same thing though, okay? 27 to the power of 1 over 3. What does the power of 1 over 3 mean? Right, cube root, right? 27 cube root, okay? And then we have x to the power of 6. Same thing, 6 multiplied by 1 over 3, right? So x, 6 times 1 over 3. Let's do it here. 6 times 1 over 3, right? This comes 1, this comes twice. Our answer is 2, right? So x squared. So what is the cube root of 27? Cube root of 27 is 3. So our final answer is going to be 3x squared. All right, deal with the numbers first, the x later. Let's do them separately, okay? Now let's go to some exam questions. These are slightly more complicated, but uh, always remember, do not panic. If there are many times when I was solving past papers that I did not understand the question at all, but you just need to understand 70% of the question. Start the question, and on the way you'll figure things out, right? Okay, so negative indice here. Okay, negative over here, that means we're going to reciprocal, bring that down, bring that up, so we're going to have x to the power of 6 over 27 whole 1 over 3. Remember, 1 over 3, what does that mean? That means cube root, right? So apply the cube root to x to the power of 6 and 27. What are we going to get? We're going to get the cube root of 6. Nope. We're going to have the cube root of x to the power of 6 and the cube root of 27, right? So what is the cube root of x to the power of 6? That's it. We're going to divide 6 by 3, right? So we're going to have x squared over 27 cube root. We did that earlier. That's 3. So our answer is x squared over 3, right? Okay, let's move on to another question, right? See, this was super easy, 3 marks, right? Hope you guys understood. If you did not, please leave me a message in the comment section below and I will be sure to respond. All right. Again, same thing, negative indices. We're going to flip this, that, there, bring that down. We're going to have 9x to the power of 4 over 16 whole to the power of 3 over 2. Remember 3 over 2, what does that mean? We have the square root of the number cubed, right? So we're going to do that over here. Okay. So we have 9. We're going to take the square root of that. And then we're going to keep that to the power of 3. Okay, same thing with x, right? We're gonna square root x and then we're gonna put that to the power 3. Okay, bring down, we have 16, right? We're gonna take 16 square root, take to the power 3, right? uh, let's solve it over here, right? So what is the square root of 9? That's 3, right? We're gonna keep that to the power 3. Now what is the square root of x? Sorry, I meant to put x to the power of 4. All right, I'm like, what the hell? Okay, now what's the square root of x to the power of 4, right? That's going to be 2. So 4 divided by 2, we are going to have x squared, okay, to the power of 3. It's always good to keep brackets, right? Like keeping brackets always helps you. You know, it avoids any complicities, right? So 16, what's the square root of 16? We have 4, right, to the power of 3. So what's 3 to the power of 3? We have 27. What's x squared to the power of 3? X6, because we multiply these two. And what's 4 to the power of 3? 64. All right, that was super simple. And if you want, you can simplify this. I don't think this could be simplified any further. So we are going to write that as it is 27 x to the power 6 over 64, right? That was super simple. This is only for extended students who are taking extended paper. Students who are taking core, please go ahead and skip to the next video. If you watch this, that's good, right? That's this nothing bad gonna happen. It's just gonna be easier for you guys, right? But you do not need to know this if you're core, right? Extended students, I urge you to practice these questions over and over again until it becomes second nature, right? You're not going to become good at maths until this should become second nature, right? So you got to keep on practicing and put in the hard work. You know, just put 30 minutes or 15 minutes of maths a day, and trust me, you will get better. All right, see you until the next video. If you have any questions, drop them down below.